This point, being the center of the sphere, is also the center of the inscribed blue cylinder, which means it's the midpoint of this segment representing the height. So this segment on the top half will be h divided by 2, and the bottom half will be h divided by 2. Now let's hone in on this right triangle. Using the Pythagorean theorem, which says the square of the hypotenuse equals the sum of the squares of the two legs, we can write the square of the hypotenuse equals the sum of the squares of the two legs, which are h over 2 and r. Alright, now let's write h as a function of r. So solve for h. The left side is 3. We'll subtract r squared from both sides. Multiply both sides times 4. And then to get rid of the squared, we'll take the square root of both sides. Algebraically, we might say it's a positive or negative value, but it's going to be the h, which is the height, which must be positive, so we could ignore that. And there we go, we're done. H is equal to the square root of 4 times 3 minus r squared. Of course, we know that the square root of 4 is equal to 2. All right, let's take a look at part B. We're talking about the volume of the cylinder. What's the formula for the volume of a cylinder? It's the area of the base multiplied by the height. The base is a circle, so that's pi r squared for the area of the base multiplied by the height. But they want the height, they want the volume to be a function of r. Well, we have a constant, and then here we have the variable r. We don't want h to be there. We want everything for this volume to be a function of r. So we can just do a substitution because we know that h is equal to this expression using r. We'll substitute that in for h, and then everything will be in terms of the variable r. Here we go. The volume as a function of the independent variable r is equal to pi r squared multiplied by h, which is 2 times this root. And it's fine to write it exactly like that, or if you prefer, we like to have those integer coefficients up front. So 2 pi r squared times the square root of 3 minus r squared, so that v is clearly a function of r. Alright, that's it for that part. Now let's take a look at part C. What values of r are in the domain of v? Well, we know for a fact that r is a non-negative value. Or we should say it's a positive value, actually, because it's not 0 either. So we know r is bigger than 0. But what's the largest value r can be? And also, are there any restrictions? Well, we know, as we look at this function, that we can't take the square root of negative numbers. So this thing that we are taking the square root of, 3 minus r squared, can't be negative. So it must be greater than maybe or equal to 0, but if it was equal to 0, we'd be saying that the volume was equal to 2 pi r squared times the square root of 0. That would all be 0. So this can't just not be negative. It also can't be 0. So 3 minus r squared must be bigger than 0, or this problem makes no sense. Let's go ahead and solve this. We'll add r squared to both sides. We'll take the square root of both sides. The square root of r squared is the absolute value of r. And in order for the absolute value of r to be less than 3, we're saying that the distance away from 0 that r is smaller than the square root of 3. Some of you might be thinking that this is a stage where we write positive or negative, and I would say not really. You might have been taught that in algebra class, but what's really happening in a square root equation inequality, when you take the square root of r squared, is that this has to be positive, because whatever this root is, whether r was negative 2 or positive 2, when you square it, you get 4, positive 4, and the square root of positive 4 is positive 2. So the square root of r squared has to be positive. So it's the absolute value of r. So now this says it says that r's distance from 0 is smaller than root 3, which would be all these values, except that in the context of this problem, the radius of this cylinder and sphere is positive. It has to be bigger than 0 in the context of this problem. So that means we can rule out all these negative values and say that the r value has to be bigger than 0 but less than the square root of 3. And that's still the domain of this function for volume. Alright, well, I hope that this video helped. Best to ya.